Hello, everyone. Thank you for taking the time to attend the AWS Networking Fundamentals session today. My name is Aarti Raju, and I'm a Principal Solutions Architect with AWS. A number of folks attending the session today might already be familiar with the traditional data center network design architecture, or you might be familiar with the general networking concepts. My goal for the next 30 minutes is to cover the AWS networking services and features that can help you build your network architectures on AWS. So let's jump right in. With AWS, we do have the concept of a region. A region is an isolated geographical area. And within this region, we do have one or more or multiple availability zones. An availability zone can be one or more data centers that have redundant power networking between them. And within these availability zones, we then have multiple racks and then we have multiple hosts. So how does this all map into the diagram that you see here? So we do have US East 1, which is our region. It is our Northern Virginia region. And within this region, we have multiple availability zones. For simplicity, I'm just showing two availability zones here. So we have US East 1A and then US East 1B. And then within these availability zones, we do have EC2 instances, which are the actual hosts that run within the availability zone. We're going to be spending a good chunk of our time talking about virtual private cloud and the features. So what is a virtual private cloud? The green box that you see in this diagram here. I'm going to remove all the physical constructs out of this diagram and just focus on the VPC. A virtual private cloud is an isolated network that you define on this AWS infrastructure. We'll talk about IP addressing as we go, but key thing to understand here is a VPC is a regional construct. When you create a VPC, you will be asked to select a region. Once you do that, you then create subnets within these VPCs. So this subnet is very typical to what you would configure in your data center. So you create subnets that are part of your VPC network space, and there can be different types of subnets, public subnets and private subnets. And I'll be covering about the differences between these subnets and also which application goes into the public subnet versus the private subnet. Key thing to note for subnets is these, when you launch a subnet, it is within an availability zone. So subnets, as you see in the diagram here, do not span across availability zones. So in this diagram, I have two subnets in one availability zone and two subnets in the other availability zone. Now that I have my subnets, I can now launch instances within these subnets that I have. So I do now have a VPC, I have subnets, I have my EC2 instances. But there's the major limiting factor. These instances don't have any communication outside of this VPC, or even within the VPC, you still need to do certain tuning in order for the instances to communicate with each other. What are those? AWS provides a number of gateways, endpoints, and peering connections that provide you this ability to communicate either within the VPC or between VPCs or even to your on-premises network. And that's what we're going to be covering as we go through the flow of these slides. We'll talk about gateways, we'll talk about endpoints and how to use that. But before that, let's take a look at this web application from a 10,000 foot overview. I just don't want to talk about gateways and endpoints. I want to also focus on how you can use this into this application that we are building. This is a typical web application that I have. I do have the same diagram. I have the web application in two availability zones. And let's see how some of the constructs that we're talking is going to roll into this web application. First things first, let's get talking about the IP addressing. You have your VPCs, you have your subnets. When you create a VPC, today they support both IPv4 and IPv6 addresses. With IPv4, I can define a Sider block as you see here. And this could be an RFC 1918 space, or it could be any IP ranges. Key thing to note is these IP ranges are not routable outside of the VPC. The VPC Sider block can be anywhere from /16 to /28, and the smallest you could go is /28. Of course, we don't recommend you to use a /28 because you're limited by the number of IPs, and also when you use a /28, you're limited to one subnet. Remember our application that we are building. We want it to be highly available, so I need to at least multiple subnets here. You can also enable IPv6 on your VPC. Once you enable IPv6, this becomes a dual stack VPC. So what is a dual stack VPC and how can you use IPv6 addresses? So with IPv6, we assign a /56 Sider to your VPC. We also have then assigned subnets to your VPC space that are in the fixed at the /64 subnet range. Once you have this, you now have a full VPC with an IPv4 as well as an IPv6 addressing ranges. So we've built this VPC with our IP addressing. The next step is you still don't have that external communication that we're talking about. There are 5 things that are required, and as you see on the slide here, these 5 things will enable you to, for your instances, to get that outbound internet connectivity. So let's talk about them. First thing, your instances require a public IP address. This could be a public IP address from Amazon's pool. So when you launch an instance, you can select auto assign public IP address, and this allows Amazon to automatically assign a public IP address. You could also use something called an elastic IP address. A common question that we get is, hey, what's the difference between the auto-assigned public IP address versus the elastic IP address? The difference is with auto-assigned public IP addresses, during instance lifecycle events, you might lose these IP addresses. Whereas with elastic IP addresses, once it's allocated into your account, it stays there no matter like what happens to your instance. As long as you go into your account, disassociate this IP address, it stays there forever. Within the elastic IP addresses, we also have a feature where you can bring in your public IP addresses into your VPC, and we do support this for IPv4 today. So if you look at our diagram back here, I've got my public IP addresses assigned on my EC2 instances. The next thing we're going to be looking at is once I assign my public IP, I now need internet connectivity. So I need to create a gateway. And remember, this is the first gateway we're talking about. I need to create a gateway called Internet Gateway. What this Internet Gateway is it's a highly scaled gateway that AWS manages. And all this does is a stateless 1:1 NAT. It maps your private IP address to a public IP address. So I go into my console, I can create an internet gateway. That's what you see in the diagram here. Once that's done, you go into your EC2 instances route table and add a route that says any traffic going out to the internet. The next hop should be my internet gateway. And you're going to be seeing this updating the route table often. Any kind of traffic that we want to send out from the EC2, the basic rule applies. You go into your EC2 instance and update your route tables. So what we've got is we've got step 2 and step 3 covered now. So we've got our internet connectivity figured out. I mentioned briefly when we started about different types of subnets, public subnet and private subnet. The difference between these is pretty straightforward. The name indicates it all. With public subnet, you have your public IP address, it has internet gateway, and it has that internet connectivity. Whereas with private subnets, you don't have any of that. These are instances that sit inside the private subnet. So what kind of applications would run in private subnet versus public subnet? My web server, for example, remember the web server that we are building? This could sit inside my public subnet. And my database, for example, or application servers, they don't need any external connectivity. So I could put these inside my private subnet. A common question that comes up is, hey, I have these application servers in my private subnet. I still need internet connectivity in order to update my repositories. What do I do? For this, we have the second type of gateway that I'm going to be talking about, NAT Gateway, Network Address Translation Gateway. So if you're familiar with the on-premises networking world, you might be familiar with network address translation. What we do is Amazon provides this NAT gateway that you could deploy in the public subnet, assign an elastic IP, and all it's doing is doing a port address translation. So it takes traffic from your private subnet, uses the NAT gateway, sends it out to the internet, and fetches any updates that you want. So as you see here, you'll see in the route table that my private instance A has a route to the NAT gateway, and then the NAT gateway has the internet gateway attached to it. So now we've completed the connectivity piece. We've got internet connectivity figured out for our application. But there's two other important things that we want to talk about. One is the network access control list, and the other is security group. What they do is, we talked about this internet connectivity and the flow of traffic. These allows you to define the rules for that flow of traffic. And as we're talking about flow of traffic, we'll also see how you can actually capture them using VPC Flow Logs or using traffic mirroring. This is our application. My web server is in public subnet, my application server is in private subnet. Network access control lists operate at the subnet level. What this means is, by default, the network access lists are stateless. So I'll have to define inbound rules and I'll have to define outbound rules. So with the default rule, this is what you will get. You will get the default inbound rule that allows all traffic and the default outbound that allows all traffic. For most customers, this might be sufficient. But what if you want to fine tune these network access control lists? And in our example here, as you see, I have my application server. This server doesn't need any traffic coming from outside of the VPC. It only needs traffic coming in from my web server, Subnet. So in this case, as you see here, I've updated my route tables for my private subnet to allow traffic coming in only from the subnet of my public subnet where the web server resides. Similarly, on the outbound, I'm defining a rule to allow only traffic go to the public subnet. And you see the only thing that's different is my destination is still the same IP range of my public subnet. I'm only modifying the ports because I know what the incoming port is. The outgoing port is one of the ephemeral ports. The next security control you have is using security groups. These are tied to the elastic network interface that is wrapped around the EC2 instance. So if you think about when to use security groups, these are applied at the instance level itself. And these are stateful. So if you look at our diagram here, I can have a security group rule for my inbound traffic that says any traffic on port 443 HTTPS is allowed on my web server. Similarly, for my application server, I can set a rule that says any traffic. Ideally, what I want to do is allow only traffic coming in from the web server. So what I'm doing is I'm specifying the source as a security group. This is easier for you because when you specify the source as a security group, the security group can be applied to your web servers. And what it means is any web server that has the security group is allowed to communicate to your application server. So we've talked about the connectivity. The last two things I mentioned was around the logging of all this connectivity. VPC Flow Logs is a feature that allows you to log this metadata. So if you look at the flow log record here, you can see that you can see the source IP, destination IP, source port, destination port, and depending upon what traffic you're capturing, you can capture like all traffic, you can capture only traffic that's denied, for example, and you can specify this either at the VPC level, the subnet level, or specifically at a particular elastic network interface. These are then pushed to either Amazon CloudWatch or Amazon S3. The last thing is for customers looking for a little more than what they see in the metadata. This is where you will see customers use traffic mirroring. What traffic mirroring does is you create a filter, you tell what traffic you want to copy. So when traffic hits a source, you define the source. It basically takes that, copies the traffic into a destination that you specify. Remember that given this is copying packets into a destination, you're actually sharing bandwidth. And I want to call that out because that's important as you're building these large-scale traffic mirroring filters. So it's important that you know that you're sharing bandwidth. So now we've completed part one, which is connectivity within the VPC. Now let's say I have multiple VPCs. How do I now span my connectivity to these multiple VPCs? And now we have 3 VPCs here, each with their own Sider block. What if I want these VPCs to communicate with each other? Of course, I can use an internet gateway, communicate between these VPCs as you see here. But what if I don't want to use the public space? I want to use the RFC 1918 address ranges that I've defined here. So what you could do is you could use a feature called VPC Pairing. This is available for peering between VPCs in the same region or across different regions. And you can also use it to peer between VPCs in your own account or different account. The workflow is still the same. You create a peering request, you send the peering request, and the destination VPC has to accept it. Once that's done, you create, going back to our basics, you go in and update your route tables to tell your route table what the next hop is. And in this case, it's a PCX, which is our peering connection. Now I could do the same thing for all the VPCs. I go in, update route tables on all the VPCs. Some key things to note with VPC peering. You can reference security groups for the VPCs that you have that are within the same region. When you do inter-region VPC peering, you cannot do this. Also, when you enable DNS resolution on your VPC and you're trying to resolve to a public IP, Amazon will be able to resolve to the private IP because we now have a data path running between these VPCs. Some things that won't work, transitive routing does not work. It's also important to select your Sider blocks that don't overlap with each other. Last thing is jumbo frames when you're within a region is supported, but when you're crossing regions, it is not supported. So the next step is I have a data center. How do I connect from my VPC to my data center? And it's just pretty straightforward. Most customers start with a site-to-site VPN. This is an IPsec VPN. And as you might know, IPsec requires 2 endpoints for the tunnel termination. On the AWS side, we are introducing the gateway again here, and this time it's a virtual private gateway. This acts as the IPsec termination point on the AWS side. So when you create this gateway, you can select, you can give it a name, and you tell us what autonomous system number you want to use. Similarly, we need a gateway on the other side, and this is the customer gateway. So when you create a customer gateway, you tell us what kind of VPN connection are you using. Static versus dynamic. A dynamic is when you use a routing protocol such as BGP to advertise the routes, whereas a static, you'll have to manually tell us what routes needs to be advertised. You also select the BGP autonomous system number, and your side of the router will need a public IP address. If you don't have a fixed IP address, you could definitely use the certificate-based VPN. Once that's done, I go into my console, click Create VPN Connection. What this does is it creates 2 endpoints on the AWS side, one in each availability zone. And this is great because for HA purposes, even if one availability zone goes down, you still have the endpoint on the other availability zone. And it terminates on the customer gateway side that you own. So if you think about it, it's one VPN connection, but it's actually 2 tunnels. So using BGP, your VGW now learns what routes you're advertising. But what about instances behind the VPC? Like it has no idea what routes you're advertising. So same rule applies. You go into your instance and update the route table saying that, hey, any traffic that needs to go to my data center, my next hop is my virtual private gateway. Key thing to note is each tunnel is capped at a bandwidth of 1.25 gigs. And even though we have 2 tunnels, AWS sends all traffic through 1 tunnel in an active passive mode. So that's what you see here. We will send your traffic through one of the tunnels. A common question that we get here is, hey, I don't want to go update my route table every time new routes are added from my on-premises site. So you could use a feature called route propagation. What this does when enabled is whatever routes your VGW learns, it's automatically propagated to the route tables. The IPsec VPN connection is over the internet, so there's going to be latency, there's going to be like limited bandwidth that we saw. For customers who are looking for a step more with higher bandwidth and dedicated connection, this is where they can use the AWS Direct Connect. The AWS Direct Connect consists of 2 pieces. One is the physical piece, which is the physical connection that you see here. This is where an AWS router is placed in a colocation. A customer router might be in the same colocation, or they could use one of our partners. A physical cross connect is done at this location. And from there, from the customer router to the data center, the last mile connectivity is taken care of by the customer. Once we've got this physical connection figured out, and this physical connection can be a 1 gig or a 10 gig, or we also support link aggregation today. Once the physical connection is figured out, the logical connection kicks in, and this is where we use virtual interfaces. These are simply 802.1q VLAN tagging and BGP peering. So the 3 types of interfaces that we're going to be talking about are the private virtual interface, the public, and the transit virtual interface. What is a private WIF? Very simple. Think about a private WIF as any communication from your on-premises into a virtual private cloud. So in this case, we've got the physical connection figured. In order to establish that private WIF, I created Direct Connect Gateway, which is the other gateway in our series of gateways that we've been talking about. So we created Direct Connect Gateway and attached the VPCs to this Direct Connect Gateway. And these VPCs could be in any region. And now, once that's done, you create a private WIF from this Direct Connect Gateway. What this now allows me to do is allows me to talk from this customer data center that could be in any location, for example, Sydney, Australia, to VPCs in any region. Like from Sydney, Australia, I could talk to a VPC in region 1, which could be US East Virginia, and region 2, which could be US West California. So this is what the private WIF enables you to do. What about the public WIF? So the public WIF basically enables you to talk to any AWS services that have a public IP. So AWS advertises all the public IP ranges back to your on-premises, and you will be able to communicate with services like DynamoDB, S3, etc. Before talking about the transit WIF, I want to take a step back to talk about transit gateway. You're all familiar with this diagram already. We talked about the peering. Peering works great depending on the scale of your network architecture. What if the number of VPCs you have grows to what you're seeing on the screen here? It becomes complex to manage these peering connections because you have to have 1:1 connection. This is where AWS introduced the next set of gateway, which is the transit gateway. What the transit gateway does is you can now attach all your VPCs to this transit gateway. It acts as a hub and then carries traffic to the other spokes. So VPC A can talk to VPC E, or VPC B can talk to VPC D, as long as it's attached to this transit gateway. So how does this work going back to the VPN connection that we had? Same thing. I'm attaching all my VPCs to the transit gateway, and then I have a VPN connection from the transit gateway to my on-premises. So now I can update my route tables to say, hey, any traffic, send it to the transit gateway. The transit gateway has its own routing table, and for simplicity, I'm using the default here and sending everything back to my data center. So this is where the transit WIF is going to be helpful. With AWS Direct Connect, when you have a transit gateway, so this is how it looks. So I have all my VPCs that I connect to my transit gateway, and now I connect the transit gateway to the Direct Connect gateway. Remember earlier in the private WIF, we were connecting the VPCs directly. So you have now the transit gateway that's replacing that. And for the virtual interface, this is where I create a transit WIF that allows me to communicate between my VPCs that are connected to the THW and my data center. So we completed a couple of things. We completed connectivity within the VPC. We completed connectivity between VPCs, and we also completed connectivity to our on-premises. What about services from your VPC to, for example, S3 or EFS, etc.? This is where we're going to see about VPC endpoints. We do have two types of endpoint. The first one is the gateway VPC endpoint. What this gateway VPC endpoint does, let's see. So let's say you have instances that want to communicate to Amazon S3. You could use the internet gateway as you see in this diagram, communicate back to the internet gateway, go out and reach Amazon S3. But there's also, you could use VPC endpoints to communicate privately to Amazon S3. What you're doing is I'm creating a gateway VPC endpoint within this VPC. And of course, I need to update my route tables to see the next hop for Amazon. For example, in this case, I'm taking S3. For S3, the next hop will be my VPC endpoint. So today, only two services are supported with the gateway VPC endpoint. One is S3 and the other is Dynamo. And each has their own public IP prefixes that are represented in this prefix list that you see here. So any traffic from my instance can use this VPC endpoint to communicate to either Amazon S3, or if I create one for Dynamo, it can communicate to DynamoDB. For most of our other AWS services, we launched AWS Private Link, which is based on our Hyperplane technology. And this is the same technology that is used for NAT Gateway, network load balancers, etc. What interface VPC endpoint does is I can create this interface VPC endpoint. And what it does is it puts an interface in the subnets that you select and allows that private communication between your instances and the AWS services in that region. So for example, in this case, I have an SQS request that I need to do. So my instance needs to communicate to SQS, and I create a VPC endpoint. It goes to the VPC endpoint. It reaches the VPC endpoint and communicates to the SQS service. Private link can also be used for your own services. What this means is it can be used in a consumer-producer relationship to privately talk between VPCs. So let's say on the VPC on the right, I have a SaaS provider who is running a specific service that you want to consume privately. So the SaaS provider is using a network load balancer, which supports IP target groups, and they're running a service behind the network load balancer. You can create a private link in your account and privately communicate to this service in the other VPC. What this also means is you can now extend this. Like as I mentioned, network load balancer supports IP target groups, which means these IPs could also be on premises. So you can extend services from your VPC to communicate back to your data center through a direct connect or a VPN using private link. So let's bring this everything together. We talked about a number of gateways today. We talked about different connection mechanisms with endpoints and peering connections. So how does this all fit into the application that we were building? So our application is going to be in this VPC across two availability zones. You could use load balancing in order to front end your application. So we've got our subnets figured out. We've got our web servers and application servers. We talked about how this application can connect to other VPCs using VPC Pairing. We also talked about how you can connect this application to your on-premises using a site-to-site VPN connection. The next thing we talked about is communicating to services such as Amazon S3 or Dynamo using VPC endpoints. And then we talked about the interface type endpoints, which is powered by Private Link to communicate to the other AWS services that supports interface VPC type endpoints today. We also then talked about using Transit Gateway that enables you to connect multiple VPCs together, and that can also then be used to talk back to your on-premises using a VPN or using a Direct Connect gateway. I also want to quickly point out some of the features that we've launched since reInvent 2019 before we wrap up this session. We talked about interface VPC endpoints. We just launched the SES service for this support for interface VPC endpoints. So now if you have applications that require to communicate to SES, you can use the interface VPC endpoints. We talked a lot about Transit Gateway. We launched a couple of features. Inter-region peering. This allows you to peer your transit gateways across regions. And then we also launched support for multicast routing and other additional regions where transit gateway is being supported. The last thing that I want to call out is with VPC Flow Logs. Earlier, we used to have a 10-minute aggregation interval. You now have the ability to have 1-minute aggregation interval. So you have more flow records that you can use to analyze data. And with that, that's a wrap to this session. I wanted to thank you for taking time to attend this session today. And the session slides and the videos will be available on the AWS events page. Thank you, everyone.